Hi, it's Robin, back on the VIC-20 again this week. In fact, I think this might be VIC-20 month. It was 39 years ago in June where the VIC-20 was first announced. This week I have a text adventure here that I actually ported over from the original. Well, this is the Timex Sinclair 1000. This was actually the first computer I ever had. And I've also got its little brother, the ZX81. This is the US version of it here. This was actually my first computer. I briefly had it before I got my Commodore 64. Now, in some ways, this is a terrible computer by any real measurement against any computer, even like the VIC-20 and especially the Commodore 64. But it had one huge advantage for this computer nerd here. When I was 11 or 12 years old, I was a computer nerd without a computer. And this was the first computer to go below $100, so I bought one. As limited as it is, and we'll look at it a bit more later, to have something that could hook to the TV and program, I just thought it was the greatest thing at the time. There's quite a few things today. If you're bored of any particular section, there'll be an index in the description below, and usually pinned as a comment as well. So just jump ahead to the part you're interested in. So I've made a VIC-20 port of a game called Tenliner Cave Adventure, also known as the Tenliner Cave Adventure, which was originally written in 2016 by Einar Saukas from Brazil. And that was actually the first ZX81 game to ever qualify for the basic Tenliners competition, which isn't an easy task at all, and we'll get into why later. I ported it to the VIC-20. I actually expected this to be easy to do, and it was more challenging than I thought. So this was actually suggested by my friend Jason Compton, who'll be making a 5-minute appearance later this episode with a port of this game to ZILF, and he'll explain that. So let's do a partial playthrough of this game so you get an idea of it. You're in a cave. You can look, nothing there. Go north. You walk. You are in a hall. Look, there's a dragon there. East. You are in a pit. Look. Whoops. Look. A chest. Open. Actually, let's try. Look. Chest. It's closed. Open the chest. Cannot do. North. I already know what the map looks like here. You're in a lake. Look. There's a corpse. Look. Corpse. There's a key. Get the key. Okay. And there's an inventory command as well. And you have the key. South. You're in a pit. You won. Congratulations. Okay. So this is a very minimal text adventure, but you saw how it has an inventory system, it has objects, has multiple locations, objects you can look at and manipulate. And what's amazing is that this was squeezed into 10 lines of code. And there it is, the 10 lines. Let's try that one more time. List 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 lines in the basic version. So we'll look at the original and then we'll come back to this one and I'll discuss what had to be done for the port. So just to take a quick look at this computer, it's very simple. Nothing at on this side of the computer. On the back is just a single expansion port where you can plug a RAM expander in. We're not going to be using that today. And on the bottom is a channel selection switch for channel 2 or 3. And on this side is the RF output for the TV, and 3 identical jacks, one for power, one for the ear, which is actually the input, because you run it from the ear for the cassette player, the headphones, and this one goes out to the microphone. Okay, what could go wrong? I'm using the same jack right beside it for power. Supposedly it has some sort of protection on it for so that you can't damage either of these by putting voltage into them. And no, it doesn't even have a power switch. You just plug the power in and it's immediately on. How convenient. And I'm just using an Atari 2600 power supply. I don't seem to have the original for this machine. I think one of the key features of this slow computer is the both terrible but also clever keyboard. Pretty terrible to use, but it's also quite ingenious how they packed so much into this keyboard. A few episodes ago, we were talking about the tokenization of the Commodore 64 of Commodore BASIC, and essentially this keyboard forces the user to do the tokenization while they enter BASIC. I think I'll explain that more in another episode, but basically you cannot type a command or a keyword into this computer. If you see on the cursor there, it has a K in it. That means that the computer is currently expecting a keyword, and those are the words written above here. So, for example, we want to load, so we're going to press the J, and you see load is automatically typed for us. Sorry about my video capture device getting messed up due to the ever-changing video signal. It thinks we're NTSC sometimes and PAL. And then you have to type some quotes. It's expecting a string, so I'll just put empty quotes and enter. Okay, now that glitchy screen is expecting me to load a game, and I will go ahead and press play on my iPad. It's about 30 seconds. Even though the game is just 10 lines of code, it takes forever to type in, so I've saved it here. Yay, another successful load. That's always something to cheer on this computer. Okay, so now we are going to do a listing. And here's the program. The first 6.5 lines of code. And then we will list from line 7 on. Again, sorry for the interference there. Okay, we'll try running the game just so you can see. You're in a cave. Look. You see how slow it runs? Nothing. North. You walk. Look. There's a dragon. Hey, kill dragon. You died. That 0 out of 10. The 0 means that the operation completed. That's a error code. It's kind of like the Commodore's ready. And then after the slash is the line number that we were on at the end of the program. Let's look through the code a little bit here so you can see what they're doing. Now, Sinclair BASIC here has a number of limitations, but it's also got a couple unique features that allowed this game to be crammed an incredible 10 lines of code. Now, if we look here at line 1, I'm going to hold down Shift, and I think if I hit the cursor down, it will highlight line 1. See that arrow next to it there. And then, if we press the Edit button, which is Shift 1, it gradually figures out what it wants to display here. And you can see we can edit this particular line. Commodore BASIC really spoils us by being able to freely move the cursor around the screen, not only making editing easier, but also making it easier for me to show what's happening in my episodes. I don't need to do any kind of finger pointing or showing an arrow in post-production because of how easy it is for me to just move the cursor around so you know what I'm talking about. Okay, back on the VIC-20. I had far too much trouble getting the Timex Sinclair to cooperate with me while trying to do that walkthrough of the code. So I'm going to use the VIC-20. Speaking of better screen editors, but through the power of editing, I'll show the Timex code in another window so we can compare between the original and the port. And all the other footage that didn't turn out so well, it still has some useful information. I think I'll stick that as a bonus extra at the end of this episode for those of you who want to see the Timex in action a bit more. On the original version, the entire game state is encoded in a single variable called xstring, and this is because Sinclair BASIC allows string slicing, much like in modern languages like Python, and it's actually more efficient for that platform, especially because you can only have one statement per line to pack all the state into that single string. So after the let xstring equals, and then in the quotes, 100, those are actually three integer variables, 1, 0, and 0 they're initialized to. That 1 is the current room number, so you start in room 1. The second variable is the state of the chest, whether it's open or closed. And the third number, another 0, is your current inventory. So you start with nothing in your inventory. So because Commodore BASIC does not have those string slicing commands that we'll see later in the Spectrum listing, I instead broke them out into their own variables called I, J, and K. I suppose I could have called I inventory and so on. I initially wanted to just use A, B, and C, but the A variable is already used in this listing. So I just used I, J, and K. I suppose because of university math, those were frequent variables to use. And then I packed as much of the string as I could into the rest of the line. VIC-20 BASIC actually has a limit of 88 characters per line. Sinclair BASIC has a limit of 120 characters per line, but only one statement per line. But because I want to keep this compatible with all Commodore BASICs, like on the C64 where there's a limit of 80 characters per line, I limited myself to 80 here as well. You'll see that this string here cannot do, now that is 9 characters in length. The next phrase that the game will print out is you walk, and that includes a blank space at the end so that it is also 9 characters long. And every statement that the game can make is 9 characters long, and even though this wastes some space within the string, overall they come out far ahead because they can mathematically show substrings just by multiplying by 9 to go to the beginning of each string. And I see that the original Spectrum version includes a number of extra phrases which I couldn't fit into the VIC-20 listing. So I had to let them run over to line 2, and here we are. I initialized the remainder of the string by appending it to the original. And then I also found I had to define some substrings. We'll get into those later, why I had to do that, but basically because of the difference in the line length, I had to pack some extra initialization here into line 2. I named these strings just based on the commands open chest for O string, S string for get sword, and L string for look. And while the original Spectrum version on line 2 has quite a bit more to it, including printing those USR 3086. Now that's actually a machine code function that jumps into the ROM in the Timex to scroll the screen, because it doesn't natively do that. Because BASIC doesn't normally scroll the screen automatically. It actually stops execution when the screen is full. But strangely, you can include those, I guess just because they're another function, you can include them in a print statement. So it's a very clever way of getting a lot more function out of a single statement here. And line 2 in the Spectrum original prints your location. I had to move that to line 3. I had a goal importing this of keeping as close to the original as I could, but I found I had to front load a lot of the changes in the program into lines 1, 2, and 3 so that the remainder of the program could stay as close as possible to the original. So in the Spectrum original, you can see it's just input UString. That seems so wasteful, but this really underlines the fact that Sinclair BASIC can only have one statement per line. The VIC version has a lot of line 2 built in here. I had to use this relatively clumsy mid-string command because Commodore BASIC doesn't have that string slicing. You see that all the location names are squeezed in here. Again, this time it's 4 letters with a little bit of math here, multiplying the current room number by 4, and then subtracting 3 and choosing 4 characters from that location. So that's why PIT has a space in it. Again, wasting a byte to save many more so that we can calculate things mathematically. And then at the end, here's that input UString, the user's input, at the end of the line. Okay, and now we're pretty much caught up, and there should be a closer one-to-one correspondence for all the remaining lines in the program. Line 4, this is where the program starts getting really clever. Normally when you think about doing a text adventure, you'd probably approach it like, if the user types east, then do this. And it would take many statements to control just the movement of the player. Amazingly here, this is all being packed into a single statement So he's managed to include the parsing of movement and the execution of it and the map of the world all into this one statement. M meaning movement, and then parsing. If the user typed north, then this part evaluates. In Sinclair Basic, a statement like uString equals north gets evaluated for truthfulness, and if it's true, it returns 1 in Sinclair Basic, but -1 in Commodore Basic, and it returns 0 in both basics if it's false. If this is false, then this whole section here, from the 2 times the truth of this to whether the room number, is less than 3, evaluates to 0. And each of these sections here evaluates to 0 if false, but to a number if true. So that's what I've reworked here in Commodore Basic, and I had to really pack it in here. This is where we start saving some space. By having the room number in the variable I was able to greatly reduce the amount of text required and squeeze it into this line. In the Sinclair original, you can see it's using X-string bracket 1, and that represents the room number variable I. Because of the way Sinclair Basic, when I said slicing, I didn't explain that. Essentially, it lets a string variable be treated as a one-dimensional array, and you can index particular letters or sets of letters from, for example, position 4 through 10, and that array is a 1-based array. The first index is numbered 1 rather than 0, like in Commodore Basic. So that one line handles all the movement. Now, lines 5 through 7 handle all the action in the game. That's why the variable name is A, and this is a fairly close mapping to the original. I had to add some extra negative signs in to account for true being -1 in CBM Basic. And this is also a spot where I had to work these variable names in. For example, this clause here is checking for both the current state of the chest and the current inventory, and if the user is trying to look at the chest. I've shortened look down here with those variables we defined earlier. So some of these lines were very challenging to squeeze into the 80 character limit. Actually, you can see that I've gone over slightly, but because of the abbreviations I could use for like and not requiring that space when you first type it in, it just fit. It's interesting to note that in the Sinclair original, for example, the U string equals, quote, 3 kill dragon, they're simultaneously checking for the state of the inventory with that 3 and kill dragon. So very clever, being able to check the user's input and the game state in one single clause like that. Line 6 has similar elements to it. Again, just having to make use of those extra variables to be able to pack the original down into a line that works on the VIC-20. 7, I had to change a bit more. I defined a new variable called B, which is multiplying my 3 state variables, I, J, and K, into a single number called B. So multiplying the I by 100, the J by 10, and K, so I could pack those 3 single-digit integers into a single variable, which can then be compared for state. For example, here, B equals 400. In the Sinclair original, they're simultaneously checking all 3 state variables with uString equals, quote, 400 get key. So did the user type get key? Are they in room 4? Is the chest closed? And is the inventory empty? Then you can get the key. So they're checking for all those elements at once. So that's why I had to translate it into a variable, because it took up so much space for me to go if I equals 4 and J equals 0 and K equals 0 and uString equals get key. So I was able to pack it down just enough. On to line 8. And this is where the game updates its state. Your current location is offset by the result of that movement calculation done back on line 4. The state of the chest is updated as if you had opened the chest, and the inventory is also updated here. And you see that this, because I'm using integer variables, I don't need all that much code, while the Sinclair version requires a fair bit of code, but doing that equivalent in Commodore BASIC would take way more than one line. I couldn't figure out how to map that directly. You can see that those slicing commands built in to Sinclair BASIC not only allow you to read a section like Commodore BASIC does with mid-string, but also allows you to, on the Sinclair BASIC, to replace a section of the string right in memory without having to rebuild the string, while Commodore BASIC forces you to rebuild the string where you would go a string equals mid-string of a string, blah, 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 and append them together plus something else, plus high. This is just an example. You can't just replace a section of a string. You have to rebuild it in one way or another. Okay, and now the Commodore BASIC has become a lot simpler. Line 9 in the Sinclair version has more of that screen scrolling, and it shows you the results of what you have done. And it's the same sort of thing where all the possible results, did you take something, did you die, did you win, is all calculated there just in a single print statement. And finally, line 10, very simple. If A is less than 11, then I had to go to line 3, and the original was line 2. It's interesting that Sinclair BASIC, one of the versions of this game, not this one I used to port, there's a slightly different version, actually had a mathematical calculation this last line because it allows go to any integer, including one that's calculated, while CBM BASIC doesn't allow that. Okay, that's how I did the Commodore port of Tenliner Cave Adventure. And now I'll send you over to Jason, who will show you his port of this game to ZIL.
Hi, I'm Jason, and I'm joining 8-Bit Show and Tell to show my port of Tenliner Cave Adventure to ZIL, which is the language that Infocom used for its classic text adventures from the 1980s. Now, Infocom would write code in ZIL and create Z-machine binaries that could then be run on dozens of different platforms, including most 8-bit computers with at least 32K of standard memory. The Z-machine would take a longer video to explain, but in modern terms, it's a virtual machine that is emulated by your real computer when you play an Infocom game. Now, I'm running Mini Zork, which is Infocom's only official release for the Commodore 64, which could be run from tape or as a single file load from disk. I'll come back to that fact in a minute. My port of Tenliner Cave Adventure was coded for ZILF by Jesse McGrew. Now, ZILF is written for .NET Core, so it requires a modern computer to run and compile ZIL code, but once you have the binaries, you can run it on everything from classic Game Boys to modern smartphones, and of course, my favorite 8-bit, the Commodore 64. I'm grateful to Jesse for his hard work on ZILF and for helping me through a few questions with my coding process. Now, I could have run Tenliner Cave Adventure on my Mac, where I wrote and compiled the ZIL code in ZILF, but I'm going to show it off on the 64 Ultimate using a new Infocom interpreter for the Commodore 64. Osmu, created by Johan Björnsson and Frederick Ramsberg. Osmu has a few neat features, including the ability to create standalone, single-file playable games. That was very common for text adventure platforms like the Quill and Paw, which were very popular, especially in Europe, where the tape drive market was dominant. But except for Mini Zork, Infocom never really catered to that market. Now, Osmu has a really cool web interface that lets you build playable Commodore 64 versions of most of the modern Z-machine games. And if they're small enough, they can be packaged as a single file. Tenliner Cave Adventure, as I'm about to show you, thankfully, is small enough. You take a look at the disk here. We're going to reset into the 64 Ultimate's BASIC. And you'll see that it's about 20K in size. Yep, 80 blocks, 20K. So, once Osmu Online is done packaging the interpreter and the game code file together, it's about 20K, and that's small enough to load and run entirely from the Commodore 64's memory. Now, my goal for this port was to learn a little more about coding in ZIL. The ZILF compiler comes with a standard parser and dictionary that is way more powerful than what 10Cave offers in BASIC. I decided not to reinvent the wheel, and I stayed with the ZILF default libraries. So in my version of 10Cave, you can have more than one item in inventory, you can use abbreviations, you can put more than one command on a line, and you can use synonyms like take and get interchangeably. So it's not as authentic as Robin's port to BASIC 2.0 because most of the system responses are wordier than 10Cave's are. So my port of Tenliner Cave Adventure relies on way more than 10 lines of code. There's about 140 lines in my ZIL file, and there's several thousand lines of code if you count the ZILF libraries and the Osmo interpreter. It probably jumps to tens of thousands of lines of code once you start talking about the actual guts of the ZILF compiler. But the gameplay is the same. We walk through, we go over to the corpse, we examine the corpse, take the key, we open the chest, and we can get the sword. We can use take and get interchangeably. We have the sword, we go to the dragon, we kill the dragon, and we win. I put in a little point total there because it was easy enough to do. We can win it in a very short number of moves, and we can even beat this version of Tenliner Cave Adventure in a single line of commands because Osmo and the ZILF library let us stack commands. So if we just let that roll, we're in a hall, we're in a pit, we're in a lake, we get the key, we go back south, we open the chest, we get the sword, there's a more prompt, pausing because it's filled the screen with text. We clear that, we go back to the hall, we kill the dragon, and we win. Thanks for watching.
So Jason also made a VIC-20 version of his ZIL port using this player from BitShifter. Now this requires at least, I think it's 32 or 35K of expanded RAM on the VIC. And here we go, I've loaded it up. You are in a cave, and this is using the interpreter ZILF that runs on a VIC-20. And Jason already demonstrated this, but I just wanted to show that it does indeed work on the VIC. You're in a hall, there's a dragon here, east, there's a pit, north, there's a lake, and so on. Alright, thanks for watching. I'll include links to the original Spectrum version of Tenliner Cave Adventure down below, and also to my Commodore port and to Jason's ports of the game. This is the official end of the episode, but I will include some of the outtakes from my previous attempts. It actually took me a really long time to put this together. I think mostly due to the technical difficulties I was having with recording that machine. Thanks for watching, and we'll talk to you next time. But on this computer, there's sort of a way around here. We can see to use the cursor keys, you actually have to hold down Shift to get any of the red symbols here. So here, we'll move along. Now in Sinclair BASIC, you can only have one command per line. I've got here the Timex user manual for the Timex Sinclair 1000. And chapter 21 here, for those who understand BASIC, if you already know BASIC, then you should not have much trouble using the Timex Sinclair 1000, but it has one or two idiosyncrasies, and then goes on to list at least 6 idiosyncrasies. So for example, words are not spelled out but have keys of their own. Sinclair BASIC lacks read, data, and restore functions. String handling is comprehensive but non-standard. That's the secret to how this game in particular was made. The Timex Sinclair 1000 character set is completely its own. Yes, it's not ASCII. It's not even something similar like PETSCII. It's totally its own. Sinclair BASIC only supports a single instruction per line. That is, you can't string multiple instructions together on one line with a colon between, like in most other BASICs. So the solution is, instead of having a whole bunch of different variables, the author here ingeniously packed basically the whole game into this string, X string. Let's move over here. I'm moving that L cursor, just says that the cursor is expecting a letter at this time. And here I'm just moving that L over. So where you see here 100, that is a string, and that's the entire state of the game. It's essentially 3 variables set to 1, 0, and 0 currently, and then all the strings of the game are packed in afterwards with cannot do, like here, cannot do, and then if you go over 9 more characters, I will very tediously go there. It redraws the whole line every time. This is terrible, eh? Okay, we won't spend... We'll try to get out of here quickly. I'm probably going to fast forward this for you. Okay, here, and here's another string. You walk, then opened, closed, a sword, a key, and so on. And if we shift down, we're now looking at line 2. Line 1 essentially defines the start of the game and most of the game state. Line 2 here prints out the current status, so it shows print tab. Those USRs are equivalent, that's the user, like a machine language function, like a sys command in Commodore Basic. Commodore Basic actually has a USR command as well. And it's calling that particular routine scrolls the screen up a line, because Sinclair Basic by default when you print just fills the screen and it actually kind of ends with an error that you can continue from. But in this case it pushes the screen up kind of like a normal computer. And it's interesting that you can inline a user call, I guess because it's just another function, right into a print command, even though it doesn't print as such. It's also interesting to note that functions on Sinclair Basic don't have brackets around them for whatever reason. Okay, and that prints you are in a, and if you see each location just takes 4 letters, cave, pit, hall, or lake. Pit is only 3 letters, so they had to add the space just to keep it. So mathematically, they could print a 4-character substring without any extra logic. Sometimes you waste a byte to save many more. And if you see on the 3rd line, it says val x string bracket 1. That means to take the value of the character at position 1 in X string. Sinclair strings essentially can get treated as arrays where you can access each section of the string as if it's in a one-dimensional array. And that's actually like some modern languages that handle slices in strings. Oh, that's glitchy. There. Oh. So that valx string is extracting the value in that string, turning it into an integer, and then multiplying it by 4, subtracting 3 to get the correct position. So that handles our location. This is the one point in the program that looks very wasteful. The whole line is just input uString, and this really underlines the fact that yes, Sinclair Basic cannot do more than 1 instruction per line. So that's just getting the text from the user uString, and that's it. Now line 4 is responsible for all the movement logic of the game. Notice that whenever you assign a variable in Sinclair Basic, you have to use the let command, and that's part of how they simplify the parsing. If they allowed you to just type in a variable name at the beginning of a line, there would be some ambiguity. What does that letter mean? By requiring the let command, which is part of Commodore Basic as well, but very rarely used, by requiring that, they eliminate the ambiguity. Normally when you would type this program, you'd think, okay, well, I've got 4 locations, and I'm going to have an if this, and if they typed in this, and if you're in this room, then you can move to that location, and so on. If you've done a bit of basic programming, you think, boy, that would take quite a few lines of code, especially if you could only put 1 instruction per line. Ingeniously here, line 4 is so long because he has turned all that processing into a single big equation, where each section, M for movement, if uString equals north, then that evaluates as true, which is a 1 in Sinclair Basic. It's a -1 in Commodore Basic, so I'll explain that when I get to the VIC-20 version. If the user typed north, then that clause, uString equals north times 2, or 2 times uString equals north, That will either evaluate to 2 or to 0. Okay, I've got the Timex Sinclair set up here. New camera angle. And I'm choosing this camera angle because the keyboard of this computer is both terrible and very clever. Terrible because it's just this flat membrane that really gives no feedback whatsoever, and it's absolutely crowded with different functions. I think it was interesting to me as a kid, but it's pretty terrible to use as an adult. This keyboard and the accompanying ROM, operating system in BASIC, force the user to actually do much of the tokenization, the parsing of BASIC automatically just by using it. So when you turn on the computer, you get this K cursor here, and that means it's expecting a keyword. And those are all the words in white at the top. Like here's print, for example. When it's in this K mode, keyword mode, you press the button and the whole word print immediately appears. You can't type in the command print or the question mark for that matter and have it actually understand you. It must be in that command mode, or must be in that keyword mode, and then it types the whole thing for you. It's billed as a convenience, but really it made it so that they could greatly simplify the logic of keyboard entry with this computer. And then you have to use the single shift key down here to get the quote. When you hold down shift, then all the tokens in red become available with that quote. And then we can go high. And you see how the keyboard shifted to L mode. That's because it's expecting letters now. And if we close the quotes and press enter, sorry about the terrible reception here. There. Hi. Okay, we're just going to take a look at the original program here. I've had a lot of trouble getting stable video capture out of this device. I was going to give you more of a tour of this, of my Timex Sinclair 1000, but we're going to have to skip that for this episode. And I'm just going to get some capture of the program here, both running and listing. And then we'll go back to the VIC-20 and talk about it more, where I've got better video signal. Program's loaded here. We're going to run it. You are in a cave. Oh,